Hello and welcome to this video on Rust programming. In this video, we will explore the memory side of Rust language. So first, what we are going to do is we are going to understand how the memory works on Linux or Windows for a process. So memory is divided into four parts of a process. By process, I mean a running program. Okay, that is the definition of process. So whenever you run a program, the memory allocated by that program is divided into four parts. One of them is stack, another is heap, one is data segment, and another is code segment. So stack is usually limited in nature. Okay, it is defined by the operating system. Heap is the largest area of memory available. Then we have data segment, which has two parts. One is called initialized data segment, another is called uninitialized data segment or BSS. BSS was name of an assembler, a very old assembler, which stands for block started by symbol. And then we have the code segment. So in your program, when you write a program, the data segment and code segment are part of the binary. The executable, which is made of the program, contains the data segment and code segment. And when it is run, it goes into the memory or RAM. Stack and heap are not there in a program. That is, the binary which you have on your hard disk does not contain stack and heap. And these are constructed when a program is run. So one of the first things which I would like to show you is that how much is the stack size for a process in RAM in Linux. So the command to check is ulimit -a. Once you have that, you can look at stack size, and this is 8 MB. This is in kilobytes. You can change this, but usually we don't need to change it. Unless you're doing massive multi-threading, you don't need to change this. 8 MB is usually more than enough for a process. So now we know that we have a limited stack. What about heap? So the heap would be the almost all the memory because stack is very little. So suppose I have these many processes running on my system. So each process will have 8 MB of stack. So you can assume that if I have 40 GB of memory here, roughly 40 GB, then you can think like we will have close to all of it available for heap, with the exception of what is given to stack and other things. So heap is your largest memory thing, and that's where the dynamic allocation happens. We'll come to dynamic allocation happens. What is dynamic allocation? Stack contains the primitive types like integers, floats. Those things are kept on stack. Simple variables which have predetermined size and are very small in nature that goes to stack. Uh, to heap, it depends on the type. For example, a string or a vector will be kept on heap because it can grow to quite large values. So, for example, the length of a string could be 16 exabytes because the length type is of size underscore t on C and U64 on in Rust. So it will have very large value, 16 exabytes. So string can be very large. So behind the scenes, it is put on heap. Similarly, for vectors, the elements can be huge in number. So you put vector in those heap. We'll also see that how we put our own variables in heap. Now we talk about data segment. So usually in C, we have global variables and static variables. If you initialize, and it goes to the initialized data segment, and if you don't initialize, it goes to BSS. But in Rust, global variables just cannot be non-static. and you can't initialize global variables just like that. I'll show that in a minute. So almost nothing will go will to BSS or uninitialized data segment. Initialized static and const variables will go to initialized data segment, and code segment will contain the assembly of the code. So let's see this in a program. So I have a static numbers. By semantics, the global variables should be all uppercase. Now it's an array of size 3 and contains I32 and three values 1 to 3. We have another variable name, which is a string slice of type const, and that is called Sheep. Now let's see if we want to declare a variable called age is equal to say 5. What happens then? So if you do this, the Rust analyzer will show you that consider using static or const instead of let. That is the thing you have, okay, from the compiler. If you want to see the compiler diagnostics, you can see it here. Let cannot be used for global variables. Okay, so you just can't declare global variables just like that. The reason for not allowing global variables is that it is a shared state. Okay, and Rust will not allow you to mutate shared state without synchronization primitives. That is, unless you use RC or ARC, those kind of stuff. We'll see what is RC and ARC. Those are reference counted and atomic reference counted variables. You just can't have shared state in stack. Okay. So one of the ways either make them static or make them const. Okay. Now we have seen this. Now let's see if we can declare mutable static variable. Okay. So you see, we can declare mutable variable, global variable. That's not a problem if that is static, because the life and note that the lifetime of static variables and global variables is throughout the lifetime of program. Okay, so now what is this? Oh, provide a third type. Yeah, I32. So we have our mutable static variable and all those things. So we don't, we have discussed this, and now we focus on how we can get something on heap. So the way to put any variable on heap is you use box new. Okay. So I have 5 here, which is of type I32, and the variable is X. Then we have another 5, and then we have a string. There is no point with string making string in a box. The reason is string as such goes on heap only. So there is no need of creating it inside a box. In any case, it is there. So now we see that these are box variable. How can we dereference that? So it's the same as C programming or C++. You put a star before the variable and it will be dereferenced. Suppose you have a custom type and you want to allow star here the reference operator to work, then you will have to implement something called a trait, and the name of that trait should be mem trait. Sorry, deref trait. And if it is a mutable box new, then that should be deref mute trait. You have to implement those traits before you can do a star on the box variable of that type. That is one thing. Now we have this, so we can multiply and we will get 25 here for Z, and star S will be shared. Now the question is, if you're coming from C++ background, is that when you dynamically allocate something on heap, then you need to either free or delete the variable. But in Rust, we don't do that. Rust does this automatically. Whenever a variable goes out of scope of any type, the memory is reclaimed using something called RI. Okay, RI stands for resource acquisition is initialization. Now, the destructor is called whenever the variable goes out of scope. If you have a custom type, then you need to implement the drop trait for that custom type so that it is dropped when it goes out of scope. Okay, that is how you implement the destructor in Rust. But unless you are doing something out of the safe code, unless you are writing unsafe code, that is not required. Everything will be dropped when it goes out of scope. Now, what else can we discuss here? So we can try to run this program and see the output. So, okay. So you can see X is 5 here, Y is 5, and Z is 25, and finally it is shape. One more thing is that in C++, you can specify to the compiler, say for example, a loop variable should go to a register of the CPU. There is a register keyword. Rust does not have a register keyword. The compiler takes care of placing the variables smartly on registers. So there is no register storage class in Rust. So why I'm telling these with reference of C++ is because when you do the comparison, Rust is very close to C++ compared to other languages like Java or PHP or Python. So it is not fair to compare Rust with those languages in terms of semantics and performance. It is just not fair. Okay. Now we have this. We have not yet covered the multi-threading, so I will not discuss RC and ARC types right now. We will discuss once we go into the multi-threading topic. So I think we have covered quite a bit. So now one of the things we should know that, so for example, in C or C++, it is possible to leak memory. But Rust compiler won't allow you to leak memory because it is memory safe. So if you write some sort of code which will leak memory, now when I say leak memory, I'm talking about safe Rust, not unsafe. Rust has two parts. There is a keyword called unsafe. So unless we are using unsafe part of Rust, memory safety is guaranteed to you. In extreme cases, there might be possibility of leaking certain memory, but we'll get into those deep topics later. In general, it is very, very hard to leak memory on Rust because the compiler takes care that the code is written in such a way that it is not possible to leak memory. So for most of the cases, you can be relaxed that something wrong will happen. As long as the program compiles, it will run correctly without problem. So I think we can end this video here. And in the next video, I will start with the generics because the reason of doing generics is that I want to talk about traits first because traits are a large part of Rust, how the language and types we have. Traits control a lot of that. And generics I will cover so that we can go and study standard library types like vectors and map and all that because that will help us write data structured programs and all that. So I will end this video here. If you have found this video useful and informative, please subscribe and share the video, like the video, because that's how YouTube algorithm will make sure that it reaches to more and more people and help others as well. So thanks a lot for watching. Happy programming.